Hello, Assalamu alaikum. I am GM Mohammed Apurbo, and today I'm going to talk about the paper which I have read named Network Intrusion Detection using Natural Language Processing and Ensemble Machine Learning. So let's get started. So the table of contents I have arranged are the introduction part, the motivation, contribution, methodology and experiment, results, limitations, future work, and the conclusion. So let's start with the introduction. So, the document we are going to talk about discusses a proposed intrusion detection system, which can be also named as NLP IDS, that utilizes natural language processing NLP and ensemble based machine learning to detect network intrusions. This system converts natural language HTTP requests into vectors using NLP techniques, allowing for the training of machine learning models to detect anomalous traffic that could indicate potential threats. Unlike traditional intrusion detection techniques, which rely on known attack methods and patterns, the NLPIDS is capable of detecting unknown or zero delay attacks and unseen malicious traffic. So now let's get into the motivation. At first, we are going to discuss about the detection of the unknown attacks. So, unlike traditional intrusion detection techniques that rely on attack methods and known patterns, this NLPIDS is capable of detecting unknown or zero-day attacks and unseen malicious traffic. This means that the system can identify and protect against new and evolving threats that may not be captured by existing methods. The accuracy is also improved here because the NLP IDS outperforms existing methods in terms of accuracy, as shown by its higher F1 score, which is 0.999. This means that the system can accurately detect and classify network intrusions, reducing the risk of false negatives. Reduced false alarms. The NLP IDS also shows a lower false alarm rate, which is 0.007, indicating that it produces fewer false positive detections. This means that the system is better at distinguishing normal network traffic from potential threats, which also reduces the likelihood of unnecessary alerts or disruptions. Utilization of detailed information. The technique works on HTTP requests that contain detailed textual information, which is more suitable for NLP techniques. This allows the system to better analyze and detect anomalies based on the specific content and the context of the requests, improving its ability to identify the suspicious activities. Lastly, integration with existing systems. Here, the NLP IDs can be used as an additional module in traditional intrusion detection systems. This means that the organizations can enhance their existing security infrastructure by incorporating the NLP IDs to detect new types of attacks. So now we know about the motivation of this paper. Let's move on to the contribution. So, firstly, we are going to talk about the integration of ML and NLP for enhanced detection accuracy. Here, the paper motivates its approach by emphasizing the synergistic impact of combining ML and NLP in intrusion detection systems, which is the IDS. The author highlights these techniques as catalysts because they contribute to an elevated level of accuracy in detecting and preventing the cyber attacks. Next comes the dynamic adaptation to unknown threats. The paper underscores the significance of the proposed module's ability to dynamically add patterns or sources of attacks not previously observed to the database of known assaults. This adaptive feature positions the IDS to effectively respond to emerging threats, making it a robust and proactive defense mechanism. Then comes the superior performance of the model compared to the existing methods. The NLP IDS is compared to existing methods using the HTTP dataset CSIC 2010, and it outperforms them with a higher F1 score of 0.999 and fewer false alarms. It achieves high sensitivity and specificity, ensuring the detection of almost all attacks while minimizing false alarm rates. Utilization of NLP techniques, mm, mainly word to vec and doc to vec. The paper introduces the use of specific NLP techniques, namely word to vec and doc to vec, implemented through the open source program called GenSim. This choice of techniques aims to leverage the power of natural language processing in building vector spaces from text corpuses, which are then utilized to train machine learning models for anomaly detection. Ensemble models. The system employs ensemble based machine learning models, including the ENSNN, ENSDT, and ENSSVM, which are later discussed in this video. Uh, and lastly comes the efficient data preparation and model training, where the document describes the data preparation process, model training using grid search and cross validation technique to avoid overfitting. So let's move on to the methodology and experiment. In the methodology, we're going to talk about the natural language processing. The GenSim tool is used to convert the paragraphs into vectors using the doc2vec model. This allows for the representation of the textual information in a fixed length vector format that can be used for further analysis. Secondly, we're going to talk about the conversion of HTTP requests to corpus. A preprocessing tool is used to extract pertinent information from the HTTP requests and translate them into English. Then comes the construction of vector space model. The documents in the corpus are then converted into vector space models using GenSim. A single corpus of M documents yields a matrix of M into N, where N is the fixed length of the feature vectors. Later, the combined matrix is split into training, which are stored in later CSV files. And lastly, the most efficient technique is ensemble machine learning, which is a two-stage framework where supervised classifiers are used for classifying the data. These individual classifiers uh, classification outputs are fed into an additional classifier known as the ensemble classifier. Then comes the dataset and results. So the dataset which is used here is the HTTP dataset CSIC 2010 in order to validate their proposed method for network intrusion detection. This dataset contains normal and anomalous HTTP requests targeted at an e-commerce web application. The results of the experiment showed that the proposed NLP IDS outperformed existing methods in terms of its F1 score, which I have discussed before, which is 0.999, and false alarm rate of only 0.007. The system demonstrated high accuracy in detecting network intrusions, including unknown or zero-day attacks. And lastly, the ensemble-based machine learning, such as ENSNN, ENSDT, and ENSSVM, performed the best with almost 100% sensitivity and specificity. Here are some data which I have added from the paper. Here we can see the comparison of the individual and ensemble models and their scores. Now let's talk about the limitations. The data set is limited because uh, the study utilizes the HTTP dataset for validation, which may not represent all the possible network intrusion scenarios. A broader and more diverse dataset would strengthen the findings and generalize the results. The lack of scalability analysis is also seen. The scalability of the proposed NLP IDS is not addressed in the paper. It is important to evaluate how the system performs in a large-scale network environments with high traffic volumes and diverse data sources. So we have seen the two limitations which we have found from the paper. And now let's discuss about the future works of this paper. Firstly, integration with real-time network traffic. The proposed NLP IDS system uses a dataset to train and evaluate its performance in the future. It would be interesting to integrate this system with real-time network traffic data. And lastly, investigation of other NLP techniques is also seen, where this document focuses on using NLP techniques such as word2vec and doc2vec for converting NLP HTTP requests into feature vectors. Lastly, we can conclude that the evaluation matrix values for different classifier models and the corresponding graph depicts the values for F1 score, accuracy, precision, and sensitivity. After comparing performance of all the 11 models, the best performing model has been retained to be deployed as part of NLP IDS for real-time intrusion detection. So to conclude, it can be said that the addition of NLP and ensemble ML techniques into IDS have resulted in gaining more accurate experimental results. Here I have added the references which have been used for the datasets. So that's it for today. Thank you so much for watching this video. Assalamu alaikum.